Okay, thanks everybody for coming. Yeah, so I'm going to talk a little bit about some of the workflow we do to complete some of our products that we have for the wireless industry. As Randy was saying, we work in a few different key sectors, one of them being in the oil and gas sector, where we primarily do data management, preliminary routing, right-of-way staking, as-built survey, and drafting services for those for that sector there. We also do wireless telecom, which is what I'm talking about today. So we work with a handful of different architecture and engineering firms where they sub out their contracting work for the survey that they need in order to greenlight their projects. So going a little bit off of the last presentation, one of the main things is we do tie down right-of-way parcel boundaries. So that's one of the first things we have to do is look into that for the boundary. That's a key part of that. And then we also do commercial and residential. I threw in a gratuitous shot there next to Coors Field of us doing some survey for a downtown project. And so what I'm going to go over today is pretty much the technology that we employ to do the project. Got one project in particular we're going to talk about today. The case study itself, applying the high accuracy technology that we're trying to incorporate with all of our field tools that we use, pulling it all together with GIS, and then I'm going to briefly talk about some high accuracy technology trends. Before I get started, I guess I'll just make a quick note that this was going to be a co-presentation today. I was going to be presenting with a little bit more technical side on the GPS equipment itself, but he had a family emergency, he could not make it today. So I'm going to try to fill up as much time as I can here. Obviously not going over too long, but hopefully give you guys enough detail that we can have some decent questions to go over afterwards. So for this project, here's the technology we employed. For the GIS side, we are using ArcGIS Online, ArcMap, ArcGIS Pro, CAD, Civil 3D. For the GPS systems, we were using the EOS Aeros Gold system, the Trimble R8s. The real-time correction that we use is a virtual reference station. So in the Denver Front Range area, we're lucky to have a couple different VRS systems that are publicly out-facing, which anybody can tie into and use. Where we're able to get real-time corrections, essentially sub-centimeter, from these providers at no cost. So that's a real key. So that ranges pretty much all up and down the Front Range, which helps us out. Then we're also using the laser rangefinder LTI True Pulse 200. And then the data collectors we use were an iPad Mini 4, we had a Samsung S9, and then a ToughPad Windows. So a variety of different devices that we're able to use. And then the mobile apps that we tried to tie together was ESRI's Collector, the EOS Pros Tool app that goes along with the GNSS unit, and then for the UAV that we use, we have a DJI Phantom 4. So this is just a kind of an overview of where this project is at. So this is what we're looking at here is the compound center with a monopole. And so essentially the scope that we're looking at was we have to do boundary search, like we talked about, tie down the parcel boundary. Then we as-built the compound, pretty much go and do topo for all the existing permanent structures that are on the property itself. And then the other key is underground utility locates. Now that's not required for all jobs, but for this one they needed to have the locate to see where fiber was running in and out of the property. So that's something we contract out as a side, so a private utility locate company comes in. That's not a service that we provide. We follow them behind them once they're done with the locates themselves, then we come in behind them and survey it to add it into the deliverable. So here's kind of an overview of the area. This is some imagery that we took with the drone. So we got high resolution imagery, essentially 1.5 centimeter pixels that we're able to use for drafting and QCing the data. You can see the lease area that's on here. This actual property is it's like a construction goodwill site where people bring in their leftover home improvement projects, so tile. So there's, as you can see, it looks like a junkyard, but it's not necessarily a It was very busy when we were there, but people come in and look for extra stuff for their projects or their do-it-yourself there. And then what we're overlooking here is essentially this is after they've gone ahead and done the locates. In this scenario, we can see the locates pretty much clearly, right? So what we have is the comms highlighted in orange. So those are your fiber lines. We've got your electric, your power in red. We can see the handholds. I don't have a laser rangefinder, but then you can see the monopole in the center there. And then there was 4 separate H-frames with equipment on it. So that's something that else that we needed a detail for the deliverable. They wanted to have us to shoot in where the H-frames are at. They're essentially trying to figure out how much more equipment can they put onto the site, how many more providers can they put in the same location, given the existing square footage and what's already been there. So over here, this is the northeast corner of the property. This is where we started to run into a little bit of an issue for the field. I also have to say that, or at least point out that, so these jobs they're tight budget. So for survey side, my goal as the project manager is to make sure that we get it done as efficiently and quickly as possible. We're not really allowed to go back out, or not, I shouldn't say allowed, but going out for a second visit or taking the absorbent amount of time to collect the features essentially blows the budget on the project, right? So we have to try to figure out what tools we can use while we're there at the same time to fit it all in to make it work. And so in this situation, we're looking at, we have multiple utilities here under this obscured area. So it's the tree canopy there, and if we were going to traditionally just try to collect it, we'd have difficulty just using our GPS equipment, which goes quickest, and then you can kind of see in the lower left-hand corner there, there's the existing equipment that we need to also tie into the property that we can't see from the imagery. So that has to be collected somehow to be accurately displayed in the deliverable. So here's kind of a ground view shot of that same area. So what we've got is we have a multitude of flags. It's very confusing. We've got essentially there's 4 different utilities here. There's a water line, there's a gas line, there's 5 different comm lines, 3 in this section right here. And then we have sewer that starts over on the other side too. There's a manhole that you can't see. So we have all these assets there that we need to have collected, and our traditional workflow is to use GPS where we can, and then outside of that we go into our other tools that we have. So the first way that we solve this problem is we'd use a total station. That would be our go-to tool. Previously on all of our jobs, that was the main point. So total stations are a great tool. So there's some good pros to it. They're highly accurate, right? A millimeter accuracy, we can use them. Essentially almost every situation where we can't get a GPS signal. And we can post-process the data, so it gives us some feedback on what we've gotten and how accurate it is. The cons to it though, calibration time, the amount of time it takes the crews to get set up and then calibrated, requires both the field guys, right? We have a 2-man crew, so both people have to be used to operate it. And then you have to collect additional control points in order to offset the data, so you have to have a backsite, a checkpoint. Those have to be essentially be monumented. You have to get a fixed GPS signal on it for 180 seconds in order to really tie it down, so it takes a lot of time. Over on the left, that's the monopole, so we used it for this scenario to get an accurate elevation of the tower itself. But to take that same piece of equipment and then to traverse it over to the next spot, reset it up, it's a lot of time. So I've been trying to figure out ways to make the whole process go more quickly. So here you can see where we've got into the same area, and we've essentially going to be starting what we tested out and put into use on this job, the new laser offset routine. I've used laser offsets in some of my other jobs, and it works out really good, and it helps out, especially if you're doing one spot to shoot to many. But this new routine that we have with the other tools, especially with the new laser that we're using, we're getting great accuracy out of it, and for what the thresholds that we need essentially for utility locates, right? So they paint on the ground a 1-foot swath for your fiber. So if we're getting, let's say, 1-inch accuracy, that's well beyond the threshold that we need to collect that asset. Boundary, setting pins, range points, things like that, we're not using it for that, but for a lot of the topo work that we need, this works out as a perfect tool to go in there, and it gives us 2 rovers at the same time, instead of just having the one standard unit. So you can kind of see there, once again, the density of all the locates there with the flags coming into all this different, the cabinets and the equipment there. And then here, just essentially showing how this now just ties into collector. So this is something new that we started to use this year, since they've been able to essentially tie in the offset routine that's directly into collector now. So no custom coding on my end or any of the analysts to have to make this work. We're just using collector right out of the box, where we can essentially get the basics for what we need. The use of the base maps is key as well. Gives the guys a lot more detail that's very easy for them to see, where they can flip between the aerial imagery and that topo base map, which is pretty much the go-to standard. It allows the points to stand out. And then what I want to note on this slide is that we got, so that's our accuracy there, so tied into that same VRS system. So we're at like the threshold of about 60 miles from the actual base station itself. So it's 60 miles, it's pretty much, we're pushing the boundary for how far that we can go out and still get accurate real-time correction. So you can see that we were right inside a collector to also bring up some real quick heads-up feedback for the crews. You know, they got 1-inch accuracy on their horizontal, we got 3-inch accuracy on the vertical. And then once we did the actual offset, and then we kind of did the Pepsi challenge, we were within 1 inch of doing the offset routine for that same feature. So over on this side, we've set the first checkpoint, and then on the red dot is actually was the second point, and that became our offset right there. So then we're under the canopy there for that first one. So I guess before I go into too much further on that point, there's 3 solutions that you can use for the offsets that they have standard right now. So the first one is the range azimuth. So this is a single point, and this is where the azimuth is that bearing is being taken directly from, let's say, like a True Pulse 360. So that device has that built into it. That's a great tool, especially if you want to shoot something in the middle of the road like it has there, if you need like a manhole or a water valve or something along those lines. It works perfect for that. The range triangulation, just taking 2 points, shooting to the same spot. Software does the math for you, and then you can use that to then create the offset. And then we have the range azimuth backsite, which is kind of like essentially a total station with a slightly lighter setup, let's say, where you still have to set a backsite to it. So you have to do a little calibration to let the unit know where it's at. So in this case, for this project, the range solution works the best, because the crews can just keep moving. You can keep moving to point. We don't have to reset up once again, set up a new backsite. And essentially that's the most accurate of the 3 routines that we could get, that essentially imports the least amount of errors, the least amount of variables to come in from that routine for us to gather the data. So here's just a real brief example of how we're using the range to get those same points. So once you've acquired your first location, and this is, we've acquired your first location in the collector, at that point it now gives you the choice to now offset from that same location. And that's essentially it. So we go to offset from there, we choose our first point, and then you can see how we triangulated over to that one spot. Essentially those are the 2 points that we occupied. And then from there it switches over to the Pros Tools interface, where the actual offset math is done outside of there, of collector. So we essentially go back into there, do the two checkpoints from either side. Once you've got those two points occupied and you've shot your offset, it then gives you the choice of which of the 2 points. So you're triangulating between either in this case, the east or west side of the triangulation, which one was your point. So you can kind of see there at the top half, it landed right where it was at. And then down here in the lower side, those were the 3 flags. So we just shot the top of the flags as our point to kind of call out and made it easy. They don't always set flags for us, but what they did this time, and it would turn out to be a big help. And they were right on. I mean, I mean, you can see there, it was essentially, it's the same width they were at. It worked out to be a perfect routine for that offset. So the other scenario where we utilize it on this project is for utilities attached to the side of the building. This scenario also traditionally gives us problems when we're out in the field to capture these utilities quickly. Once again, we would either, at this point, set up a total station, stand over there with the rod, shoot each one of those points, move on to the next points. But now with this system, we at least were able to go for shoot all three of them, stand over to the side, because the other issues that we get multipath errors. So we do some small cells as well, and if we're sticking the pole up next to the utility pole itself, we've noticed some problems where we get multipath and the point showing out in the right of way, not where it's supposed to have been. And there's not a whole lot of QC tools that we have in the field for the guys to look and say, hey, look, this look right. Do we need to shoot it again? I mean, these guys are trying to go as fast as possible and be as accurate as they can as well. But their whole mission is to go as quickly as they can to get the job done as efficiently. So for this scenario, the other way that we'd solve this problem is that we tape in the building. So we would take our field notes with a field sketch. We'd manually tape off the building, measure the outside corners, and then from there start to measure in assets from inside of that. Then that document gets scanned, it goes into the project folder, then that gets passed out to the drafting team. The drafting team takes that, has to decipher that out, what they were trying to say, which asset were they talking about, put that into the drawing, and that also takes a lot of time. Obviously they like to work with points and lines, right out of the box. It makes it easier for them. So taping it is something we use as a plan B when we have to. But if we don't have to essentially, still walk around the building, do all those manual measurements, then this is a big help. So from there, this is the same screenshots from collecting that exact asset. So you're doing the same routine. You start off by occupying your point in collector, move over to the offset routine inside of EOS Pro's tool, EOS Tools Pro, and then from there you get the circles to give you the idea of where the triangulation landed at. I want to note on this one, so we were over, there was a lot of vegetation on that side as well. And so the guy that I was working with that day, immediately he picked up, he was like, hey, this one didn't land on the side of the building. Because he was shooting through what was essentially a side of a bush, that was our only other angle. So he picked up right away that it didn't land right where it should have. So you can see there, I mean, it's almost right on. I mean, this is, of course, not our imagery. This is the imagery that's coming down from Esri and from Google. And the point still from the third-party app still shows up in the same spot. So you can see our offsets there. So he knew right away whether or not it was right or not. So that saves us time, because normally that would not have happened. He would have shot it, would not have been accurate. We would have found out later, and then we'd have to have figured out another way to solve that problem. And then you can see our other points that we shot. Those are the same three utilities that are coming over to the side. So it really helped out quite a bit. So then from there, we push it up to the cloud. So we're using ArcGIS Online to then store that. We have it hosted there just for ease, so we have our project data from that point. And then from there we can directly import it into Pro or from ArcMap, so within our own portal inside of there. Take those same points that now it's synced there, pull that back in. We can ETL it out of there into the different data types that we need. So we use feature geodatabases, shapefiles, CSVs, Access. So all that can then be directly downloaded, something that I don't have to do for them. I mean, anything that I can do to eliminate people asking me to download or create a shapefile for them is a huge help on my end. Any of that stuff that they can self-do for themselves if they need in that format, and it's just essentially a right-click or a download away from them is a huge help. So from there, we can bring the drawing back right into Pro. In this case, we're looking at almost the finished product. So what we've got is we've got our boundary in red, so there's our locked-in boundary from traditional survey. We've got our 1 foot contours that we brought in from the drone. That's overlaid with the utility locates that we have along the west side of the project and the north side, so you can see the density there and all those running into the compound itself. Our high resolution imagery that we captured from the drone, lay that over there. So this gives a great reference and a good deliverable for the client as well that they can use to do some design from, because they're working off of just open source, all the same free sources of data for their imagery. So that's something we share back to them as well, because then they can use that to then bring it into their programs they're using for design. So here's just kind of a blow up of that same area, so you can see how everything pretty much lines up pretty tightly. So we have our easements drawn in, so we have the new access and utility easements that they're going to use to access the property. The goal is they want to figure out where they're going to pull more fiber, right? So they want to have more bandwidth, more fiber. Where are they going to pull that from? What's the best location to do that? If they're going to bore, which side are they going to go from? Are they going to go from the utilities on that side, on the south side, or over here in the northeast corner? There's actually 4 different pedestals in this project. You've got one in the north in the middle, and there's another electrical box on the far northwest corner. So pretty dense with the utilities that are coming in there. But having the data line up in that format is extremely helpful. And essentially, it's all drag and drop. I brought it in from the format that it was originally put in. Once it's been processed, outside of doing the imagery and that side on a one-off, everything else was drag and drop. And then we get essentially do our deliverable. So this is 1 page of the 4-page document that we deliver. So this is the site detail that they need to check the box in order to get the project to be accepted. So we normally have a parent parcel that just describes the right-of-way, where we've tied that down so they know exactly where the right-of-way begins and ends on the property. So when we write the legal descriptions for the lease areas and the utility and access easements, all those are accurate. We don't get a lot of pushback from a lot of the local governments that we got to submit these to, or that the architecture and engineering groups submit these to. And then once going through the title commitment, any other easements that were in play on the property, those are also shown on here. So this slide, what I really just wanted to show here is, so this is the next day. So we're at another site, and now we're back essentially within our, I call it our VRS bubble. I'd say we're probably only about maybe 5 to 10 miles away from this one base station. So I've been trying to test this out. I'm trying to get this to, because we're a traditional survey, we're only using pretty much one platform since I've been on board to collect our data. So I'm trying to integrate this to give us another platform to work with. And so as I'm testing it out and seeing what the thresholds I can get. So in this scenario, I'm down to 0.3 inches and 0.5 vertical. And then here's the screenshot from the Tools Pro window showing the coverage that we get. And that's the other thing too. So now we've got so many more satellites that we're hitting with this. It's just giving us a ton more base data to work with, and then tying in our receiver to be even more accurate. So so do the math on that real briefly. So we're at 0.7 centimeter horizontal, 1.2 centimeter vertical. And once again, this is all real time, all free, no coding. I just plugged in the data, then went out and started running it. Yep, the openly facing reference station, which I said is lucky. If you have one in your organization you use, or you pay for a subscription, you can tie that in here as well. What I wanted to show here on this slide was just a little tips and tricks. So they offer a toolbox that you can essentially download, bring in a pro to give you a little bit other, some metadata that you can import into your shots. So not only will it collect the GNSS fields automatically when it comes in, but you can also collect the offset metadata as well. So that goes right into your fields. Essentially, all I did was create my feature class layer, ran the script to add in their essential base fields, then pushed it up to ArcGIS Online, and then added it to my map, and then turned on the collector for the iPad, and then I was up and running. It was that easy. So no custom coding on my side again, because I'm always looking for, even though we just had a presentation on Python, I try to stay away from as much custom coding as I can. So this is something I can point you to later if you're interested in that. But it's just another way to get some additional metadata for some checks and balances for if you have to pass that off on where the data came from. So I was just going to briefly touch on, I'm by no means an expert on all the trends, but for where I see things are going in this field, at least for data collection and mobile apps, the days of having a single device that you used and sat on your desk, maybe it was only used for that one purpose, I see those as getting less and less useful. Right? I have a slew of different collection devices from the handhelds that are just GPS. I see it as being that guys in the field, including us, everybody either wants to use what they already have in their pockets, or they want to use something that can be cross-platform to use for multiple different solutions in the field. So our iPad, we're using that as a data collector. It runs our drone, does our flight paths for that. We're able to send the data and sync it all from the same device. And then we can switch over to an Android device if we want to do the same thing on the next day without having to essentially switch gears, reload data dictionaries, a lot of the manual maintenance that we have going on with some of our survey equipment. It can be a burden. It's a time suck for sure. So the mobile apps, pretty much what you're talking about here, increased customization across all the operating systems, having one app that works on any of those devices. I definitely see that happening. The laser rangefinders. So I've 3 different versions of those that we've been using, and they're getting more accurate for cheaper, just like everything else, right, that we're using. And that's what we're looking for. So on the UAV side, better sensors, lower price on those, and then be able to incorporate multiple sensors on the same platform. I'm looking forward to that. A lowest price point as possible, get as many birds as we can to share out with our field crews that can collect as much data as possible with a single path, right? So that would be ideal if we could get, it's out there, but the price I think is going to come down to where it's affordable to everyone soon. And then on the GIS side, improved map sharing and data sharing. So like you were talking about with the county governments, I see that as coming in next. The open data side from the data holders I think is going to be becoming a little bit more accessible, and that's something we have to do on our end and for survey all the time as well. We have to track down free data, see what's available from your local governments, from counties and cities, municipalities, towns, get what they have. If they don't have any, then we have to find a third party to get it to at least start our base mapping to get the project rolling. So I see that as coming. It's obviously something big that ESRI is pushing. The open data portal is definitely heavy, something that Jack, that every time I've seen him, he's talked about. And I came from the local government side where holding your data tightly was the key to the operational structure. I think that's going away. I think that the more it goes out there, they're finding it better use, and they're contractors for such as ourselves. Why not have their base data to work from instead of creating it from scratch? So just a quick recap. So with our projects that we do, like I was saying, it's tight budgets, right? Everything that we have is, not everything, but especially for the telecom side, it's very little room for error. Very, very, very short window in order to get the job right the first time. Going out a second time is essentially a bust. If you can't get the job on the first day, it usually is not going to work. Don't know what tools are going to be necessary till we get on site, so there's no prereq. We don't get to go out and scope out the scene to kind of get an idea of what we're going to be able to use when we get there. So we show up, get out there, and figure it out on the fly. Having team members that are problem solvers is key. A lot of hand holding for lots of office calls that also slows it down. We need the guys to be able to figure this stuff out on their own and keep moving. So the field challenge is there. Bring your own device, be able to take these platforms on many different devices that we have, whether it's our own phones that we're using or company-sponsored devices that work across all the different platforms. And then having RTK laser mapping being essentially now at a price point and a usability level that's getting sub-centimeter accuracy, at least for horizontal. That's a huge help for us. If you're doing sub-meter, right, and you're trying to find something, your threshold is within a foot, well, that's not going to work. But if you can get that same thing for around the same price, well, now it's very usable. And then obviously trying to get the deliverable on time. Tying all these things together in order to get there to the right point as quickly as possible. That's it. Sorry, a little blunt. You guys have any questions?
Did you use the EOS GNSS for ground control points on the site also for your UAV?
We haven't used that yet. It's only because I'm still working out the to tie down the Z on that device versus the other ones that we're using. At this point, it is accurate enough that we could use it, so there's no reason why we can't. We just haven't done that yet.
Because we've used it to get ground control points and then create the 1 foot contours from that data.
There's no reason you can't, right? I mean, until
work perfectly.
Yep. If you're tied into the base station, you're getting those real-time corrections. I mean, if you're sub-centimeter, that's more than enough accurate to get that.
So we use laser rangefinders as well, but not to those accuracies where the traditional, reflectorless total station data link is going to be able to get
Right.
to millimeter. You guys are truly seeing rangefinders hitting millimeter accuracies.
An inch for that routine for the range. We were within an inch.
Okay, I'm sorry.
Yeah. So now
Wow, that's really tight.
Yeah. No. Total station. Right, we're getting that, but for once again, if for those assets where we need to do just topo, it's working. That's where we're seeing it fit in. And I can have 2 crews going at the same time, where we only had the 1 rover. Now I've got 2, so now the job's getting done even quicker.
Yeah, True Pulse 200. I like it as well. I mean, you stick to telecom with the fiberglass, poles, and then you go from there. You get the power.
Yes. Yep. So we have. Are you talking about the pole, the range pole?
Correct.
Yeah. So we have. I actually have a steel one. It's the heaviest one that I like the best, but we have a fiberglass setup that we use as well. So carbon fiber one, but essentially getting the right attachments on it, it seems to have been fine.
I don't recommend the steel in the rain. Okay.
I don't either. It's heavy, but it's sturdy, which is what you need, right? So that's fine.
So, but the triangle, the Bluetooth, that's a great idea. I mean, I know that it does the Bluetooth, and that works pretty well when you do that triangle system.
Yeah, it works fine. We had no issues. So we're tying into both devices, so Bluetooth to the EOS and then Bluetooth to the GPS. They're both tied into the same thing. Once I've gone through the offset routine, the data populates over on the other side. And then, like I said, what I like best is that it immediately shows me where that shot's at. So before, I mean, without some sort of base data to give you some sort of, control element to see where that shot landed, normally the guys would just move on to the next shot, right? They weren't even double checking.
And that's why you use the collector the True Pulse, because it does get within an inch. I know that, but the rangefinders, they don't get you within 2 feet or way out.
Right.
And also, I want to ask you, so do you check that with your collector mobile app? So when you guys are, doing all your underground or aerial, when you're actually setting that, the collector gets you pretty close, but how does the Bluetooth? I mean, is that doubling it? Is there you kind of checking your GPS? I'm just curious.
Well, we're using 2 separate devices on it, so I'll go over and shoot the same point twice. So I'll have the guys either, or if I'm out in the field, I cherry pick the good jobs to go out. I don't want to sit I don't want to be in the office all the time. So I get to cherry pick those ones. But yeah, we'll set up on top of each other, and we're within less than centimeters when we're doing it with the clear sky. Now, if you're under a canopy and you're getting some of that distortion. But once again, the other advantage is, once again, we need to be within a foot on some of these utility locates, right? So if we're at, let's say, 6 inches and we just need to get the shots to keep moving. I didn't show the slide up there, but I had a couple shots where we were partially covered and we were still within 3 inches, right? So we weren't getting that before. So it was essentially lost initialization, go back out, gain initialization again, and try to do the wrong survey move of running in the point, right? So you're running it in there while it's still fixed, try to get the shot. And you can do that 5 or 6 times, it won't work, but this did work. So for that scenario, it was fine, and with the Bluetooth, it wasn't an issue. Yeah. Anything else?
How long does it take you to turn a project around? So when they go to bed, someone working in the office or working on the tower?
2 weeks.
2 weeks.
You get a 2-week window to get it done. So depending on the pipeline, how much we've got in front of it for our drafting team, you know, it's essentially fitted in, or put it in the queue to get going. So doesn't typically take us that long, but you know, I've always put a 2-week window on it just to make sure if something comes up that I'm not saying I can deliver and then can't. That's worse, right? So nobody wants to go over it; they don't have to. How long does it take us before they can start drafting? They can start the next day. So that's the other key, or even that afternoon. Some of the Opus data that we use for our other crews that we're using out in the remote areas, they're not using, you know, we don't have the system set up for them yet. We have 26 crews that we have data coming in from every day. So we have crews in essentially down in New Mexico, Texas, based out of Carlsbad, and northern Oklahoma, and Kansas, and then Colorado. So we have data coming in, you know, every day. So for these ones, essentially I could get them going on that afternoon once they get back, because we have no post-processing, right? Everything's real-time corrected. The only thing that takes the longest is the imagery, right? So that whole drone workflow is essentially it's an overnight, but they can get going on everything else, locking in the boundary, everything like that same day. Anything else? Well, hey, thanks again. Appreciate it. Thanks, Randy.